All right, so we're going to use the metaball now to break some constraints. There's a thing in dot networks that is really powerful and cool called a SOP solver. So SOPs, we know what those are certainly by now. Anything out here really. But the SOP solver allows us to make changes to a simulation on the fly using SOP tools. So make a SOP solver and hook it into this third input where it says constraint solvers. If I dive into this, I don't see anything. But you'll see there's multiple inputs into this. This relationship geometry, the last one, there are constraints. Now an interesting thing about this is we can change it using, again, regular SOP tools, and then feed that into this output here, and that will become the new result. So what we need to do is break these constraints based on the metaball. As you might imagine, object merge in our metaball force. So I'm going to say copy that to here. And we know on frame 3 that metaball is a thing. So there it is. And what I want to do is say there is a group on here called broken. This is a group that's recognized by the actual bullet solver. What it means is the constraints will still exist here, but if they are in the broken group, they will not function. So we need to put a bunch of constraints into that broken group when that explosion goes off. And the way we do that will really just be up to us. What I'm going to do is say primitive, or rather, let's do a point VOP. We'll do it in this side stream here. And we'll read in that metaball. Now, there's a VOP here called metaball weight. Normally I would do this kind of thing in Vex, in a Wrangler, but unfortunately the metaball weight function is a little harder to use than the VOP version. So put the position here, and for file, put input 2, because input 2 was this. So it's treated as a file in the VOP. That's why it's the same color. So read, for every point, read the weight, and then I'm going to export that to an attribute called weight. You'll recall that the weights of a metaball go from, at least by default, 2 at the center, and they curve down towards 0 on the outside. So here we go. If I click on the eye here, I can click weight to hopefully make a, oh, maybe I didn't get it. Try it again. That should make a visualizer for it. I don't really see anything, perhaps because the color here, I'm going to delete the color. There we go. I don't even need to do it. Anyway, so there you go. We can see the kind of heat map of our metaball on there. Now it's the primitives though that I want to affect. So I'm going to do an attribute promote, or promote. And every one of these little lines has 2 points. So I'm just going to say take the average. It'll be close enough. So I'll take the weight from point to primitive. So now this is instead a weight attribute here. I mean, it's still going to look pretty much the same here. And this is what we're going to use to decide whether we break a constraint or not. So let's make a group that we'll then use to drive that broken group. So now I'm going to do some Vex. So do a primitive wrangle and say, for every primitive, for every one of these constraints, if that weight attribute we just made is greater than the, I'll say, max, or I'll say high strength or high weight. If it's greater than that, then do something. And that something is, well, let's put it into a new group. We can define new groups with this syntax where we say, it's as if we're making an attribute, but the attribute always starts with @group_, and then the name of the group we want. And by setting it to 1, it means it's in that group. So let's look at that. Oh, no dice so far. Oh, we need a end curly brace. So we have that active group here now. So let's see what that even looks like. Active, delete non-selected. So it's quite a bit. And that's because currently high weight is set to 0. So let's make it, the higher I make this, the higher the threshold is going to be for putting these things in here. I'm going to make this super high actually. Only right at the very middle, the most intense part of that explosion, do I want to break every constraint. Because remember, we're going to break the internal constraints also, because it's so powerful right here. At the same time, I want to say else, if the weight is greater than a different threshold, I'll say low weight, then do this other thing. So if it passed this test first, if it's higher than the high weight, it will do this and end. So it will never do the second thing. But if it's not higher than the high weight, it may yet still be higher at least than the low weight. And the low weight, I'm going to say, well, we'll say this will actually do the same thing, but I'm going to have two conditions here. So if the weight is higher than the low weight, and remember that attribute we made before where we called external? If it is external, this will evaluate to 1. So you can literally say equals 1 here, or we can just do shorthand, nothing, because 1 means true. So if it is higher than some lower number, but it is actually one of these weaker constraints, you should also be included in what gets blown up. So again, we need to bring this up. I'm going to say this can just be 1. So in the very middle of the explosion, we're destroying all the constraints, and further out, we're going to destroy the, let's see, that is not what I expected to see. Maybe we should do the opposite of that. I meant earlier, I'm a little curious about that. Let's look back at our sim here when I made these. Oh, yeah, I did it wrong. I said the external constraints should be when the strength is less than that, because those are the weaker constraints, the ones that are less than the maximum threshold here. So hope you'll forgive me there, and I hope that makes sense. So we're going to have to start the sim over because it has cached currently the old constraints the way we had it set up just then. I'm going to frame 44 as well. So reset that simulation, which will load in the new constraints the way we meant to do it. And I'm going to go back to frame 3. And this looks more like how I want it. So to reiterate, with the external constraints actually marking the correct ones this time, and I'll put a little note in there later, I want to say above the high weight, destroy everything. And you can see if I were to lower this, you'd see more of the internal constraints being added in. So I hope that clears it up a little bit. And I want only the weaker constraints at it furthest from the blast. So there you go. So that's in a group active. And as the group active, I want to copy that group over to the main line here. That was a primitive group active. And then finally we can say, we can use, there's a few ways you could do this, but I'm just going to put a primitive wrangle here so they get used to using them, and say, okay. So the active group we just carried over, there it is. So this will only run on those primitives. So we're going to update the broken ones to be 1. So now if I middle click, I can see broken includes those. I'm not trying to replace the broken group with this. I just want to say, hey, are you in the active group? You are now 1. So it's essentially, it's merging these two groups together. And just to be clean, I'm going to do a group delete and let's get rid of that active group, because I don't want it to like keep doing this every frame or anything unexpected like that. So we maintain our broken group, the one that bullet recognizes, we get rid of our active, and then there you go. And that'll do it. So let's go see what we've come up with. I'm gonna save it, come out to here. It looks nicer out here than it looks in here. So I'm coming out here, and let's see what that looks like.